So hi students, I hope you people are doing well. So let us continue to the previous class. In the previous class, we have done till we have studied some types of masses like molar mass, okay, actual mass. So next we done with gram atomic mass, gram atomic weight, all those things we are done, right? So now I have, as I said in the yesterday's class, in the last class, that definitely you people have to must memorize the molar masses because these are like our alphabets to our chemistry. Okay, so it's your responsibility to remember and write all the molar masses without saying. Okay, so let us continue the next one. Now I'm going to say few important compounds which are frequently repeated in our uh, questions. Okay, in the compounds. Okay, so let us try to understand. So the first compound, write down HCl. Okay, so the molar mass of HCl, how can you write? Hydrogen is 1 gram, chlorine is 35.5 grams. Okay, so what you are going to get 36.5 grams. Okay, so whenever I say HCl, immediately you should say 36.5 grams. Okay, in the same way, when we go with NaOH, okay, so what is the sodium? Sodium is 23, oxygen is 16, hydrogen is 1. So total how much you will get, Nana? You are going to get total 40 grams. Okay, this is the way to find out the molar mass of the compounds. Okay, now I'm directly going to write. Next one is NaCl, which is nothing but 58.5 grams. Okay. Next, fourth one, calcium carbonate, which is nothing but 100 grams. Okay. Next, fifth one, H2SO4, frequently used sulfuric acid, which is nothing but 98 grams. Okay. Next, sixth one, HNO3, which is nothing but 63 grams. Next, KOH, which is nothing but 56 grams. Next, Na2CO3, sodium carbonate, which is nothing but 106 grams. Next, KCl potassium chloride, which is nothing but 74.5 grams. Next, sodium bicarbonate, right? And its weight is 84 grams. Okay, and next few things like you can go with the carbon dioxide, which is nothing but 44 grams. Ammonia, right, which is nothing but 17 grams. H2O, which is nothing but what, Nana? 18 grams. So these are few frequently used compounds in our chemistry. You are not going to get more than this. Rarely one or two compounds will come out of this. Okay, right. So let us start with the first concept, which is very useful and we definitely will get in the NEET examination. That means important topic for the NEET examination. So the next concept is average. Okay, average atomic mass. Okay, so the for shortcut, what you can write, AAM. Instead of mass, even you can use the word what? Weight. Average atomic weight, or even you can call it as a average atomic mass. Okay, so let us try to understand the formula here. Average atomic mass is nothing but summation of percentage of abundance, into its isotopic mass, okay, whole divided by 100. Okay, so this is very important formula. You may get 1 to 2 questions in your final test series, or you can say chapter wise test. Okay, so this is very important formula, have a star mark. So now what is the meaning of this, Nana? The meaning of this symbol is summation. That means you have to go on adding the information which they provide. Okay, so when we do few numericals, then only you are going to get more clarity. Okay, so let us start to take few numericals. Right, so write down the first question here. So the question is B10 and B11 have natural abundance of 20% and 80% respectively, full stop. Find AAM. What is the meaning of AAM? Average atomic mass. Okay, so let us try to understand the average atomic mass here. Now, what is the meaning of respectively? Respectively indicates that first value belongs to first one, second value belongs to the second one. Okay, right. So let us try to understand. Since the question is related to average atomic mass, we have the formula: average atomic mass is equal to summation of percentage of abundance. Here how much percentage is there? 20 into its isotopic mass. What is the isotopic mass of boron? Here B indicates the boron. Okay, 10. Since they have given summation, so we have to do add. What is the next percentage? 80 into its isotopic mass is how much? 11 whole divided by 100. Okay, so how much you are going to expect here? That is nothing but 200 plus what you will get, 880 divided by 100, right, which is nothing but so how much you can expect? 1080 divided by 100, which is nothing but approximately 10.8 will be our answer. Okay, I hope you people understood. Let us do few more questions. Right, coming to the next question. So write down the next question here. Chlorine in natural Chlorine in nature exists in two isotopes. Chlorine in nature exists in two isotopes, that is chlorine 35 and chlorine 37. Full stop. If the ratio of their occurrence if the ratio of the occurrence is 3:1, full stop, find average atomic mass. Okay, right. So now what happened here in this case? Can say once again the question belongs to which concept? This time also the question belongs to what? Average atomic mass. Okay, we know that the formula for average atomic mass, abundance into isotopic mass, right? So what happened? You people got two things. What are those two parts? Chlorine 35, chlorine 37. Okay, first value belongs to the first one, second value belongs to the second one. Okay, so average atomic mass is equal to, what is the percentage? Now instead of percentage they have provided the ratio value. So what is the ratio? Abundance is 3, its isotopic mass is how much? 35, plus abundance is 1, its isotopic mass is how much? 37 whole divided by, we should not write the 100. What we have to do? We have to take 3 plus 1. Okay, now the question is, ma'am, in the previous question you took 100, why are you not taking 100? Still listen, what is the meaning of percent? Okay, percent means what? Divide by 100. Okay, cent means what? Divide by 100. Per means what? Divide. Okay, so since they didn't provided anywhere percent, so never take divide by 100. Okay, since they didn't provided anywhere percent, so let's what we have to divide by overall abundance. How much, Nana? 3 plus 1. Okay, so what we people are going to get here? So just do the small calculation by yourself and finally you should get answer 35.5 grams. Okay, this will be our average atomic mass. Okay, I hope you people understood. Now always remember, whenever you're listening this video class, if you have any doubt, that part, please take the screenshot and send it to me. I will explain you. Okay, when I will explain you in the WhatsApp. If not possible, then we'll go with the during our doubt clearing session. Okay, right. Moving to the next one. Write down one more numerical. Right. So an element X have average atomic mass is equal to 41.8. Full stop. If it has two isotopes, that is X40 and X42. Full stop. Then find occurrence. Okay, occurrence, or you can say abundance, both are same. Okay, so okay, I will give a small example to you here, right? So there is an element. Okay, what is the element they have provided in the question? There is an element X. It has total two isotopes. What is that isotopic, Nana? So it's isotopic mass. One isotopic mass is what, Nana? Okay, what are the two isotopes they have provided? X40, and other one is what? X42. Okay, now what happened here? If I ask you what is its isotopic mass, how much they have given? 40, and here they have given 42. Okay, but did they provided the abundance here? No, they are asking you to find out abundance. Okay, now what happened? As you people know, suppose if I go with the capsicum. Okay, as you people remember, capsicum has three colors. One is green color, yellow color, red color. Okay, suppose if I say yellow color is 20% and red color is 10%. Okay, then how much will be the green one? Okay, obviously you will say 70. Okay, have you got this 70? Because you people did 100 minus 30. Okay, that means if y and r is x, then this must be what? 100 minus x. Okay, in the same way, out of 100, if x40 is some x, suppose if I take p percentage, okay, then this must be what? 100 minus p percent. I hope you people understood. If green color, red and yellow. Okay, if you're getting more confused, I will remove the red color. Okay, if there are two capsicum, green color and yellow color. Okay, if yellow color is 20, okay, then what should be the green color? Right, if yellow color is 20%, then what should be the green color? 80%. Have you got this 80%? 100 minus 20. Okay, if y is x, then green must be how much? 100 minus x. I hope you people understood how I took p and 100 minus p. So let us try to substitute in the formula. That is nothing but average atomic mass is equal to, what is a percentage? P into its abundance is how much? 40, plus what you should write here? 100 minus p, percentage into abundance. Abundance is, that is, isotopic mass is given how much? Its isotopic mass is 42. Okay, whole divided by 100. And one more thing, average atomic mass already they provided in the question. Its value is found to be how much? 41.8. Okay, so let us try to substitute here. So how much you are going to get? 41.8. Okay, into, I'm sending this 100 this side, so what you will get? Into 100 is equal to 40p. Okay, plus what you are going to get? 42 into 100, you will get 4200 minus 42p. Okay, so if you go with the further calculation, what you will get? 4180 is equal to 40p plus 4200 minus 42p. Okay, sending this term this side, remaining that side. Okay, if I go like this, 4180 is equal to minus 2p plus 4200, sending 2p that side. So what you will get here? 2p is equal to 4200 minus 4180. So 2p is equal to how much you will get? 20, and p is equal to how much you will get? 10. Okay, now the question is, which one is heavier, which one is lighter? Okay, so which one is a heavier isotope and which one is the lighter isotope? Okay, so heavier isotope is nothing but the one who is in higher weight. Can say X42 is the heavier isotope. Lighter isotope is what? X40. Okay, now what is the percentage of abundance we took for the heavier? Right, so here we took for heavier, percentage of abundance is 100 minus p. Okay, so what we can take here? Percentage abundance is 100 minus p, which is nothing but 100 minus 10, which is nothing but how much? 90. Okay, heavier isotope is 90. Coming to the lighter, what is the percentage we took for the lighter? P, which is nothing but 10%. Okay, now the thing is that whether he is asking related to heavier or he is asking related to the lighter. Let us see in the question what they are asking. He is asking to find out both. And both అంటే ఏమొస్తుంది ఇక్కడ? What you can see, 90% and 10%. Clear till here? I hope you people got clarity regarding the average atomic mass. Okay, now let us go with the next concept. So the next concept is nothing but law of chemical combination. Law of chemical combinations. Okay, now what is the purpose of studying this concept? Okay, what is the purpose of studying this topic? So actually what happened in chemistry, whenever you do any experiment or whenever you perform certain chemical reactions, definitely you people have to follow certain rules. Okay, so whenever a chemical reaction is taking place, it is following certain theories, it is following certain rules. All those things when you are going to study, you are going to study in a concept called law of chemical combinations. Okay, so in this there are a lot of laws we have. Let us study one by one. So the first law is nothing but law of conservation of mass. So what is our first law? Law of conservation of mass. Let us try to understand what does this law says. Okay, first of all, it is given by, write down the scientist name. It is given by Lavoisier. It is given by Lavoisier. Let us write. It says that mass can neither be created, mass can neither be created nor destroyed. Mass can neither be created nor destroyed in a chemical reaction. In a chemical reaction. So what does the sentence says that suppose you people have started the experiment by taking 20 grams. Okay. So after completing that chemical reaction, is it any chance to get more than 20? No. Less than 20? No. So you will expect if you take 100 grams, then you will get the 100 gram. You are not going to get any extra mass in the chemical reaction, or you are not going to get any less mass in the chemical reaction. The amount you take for the chemical reaction, the same amount you are going to get the product. Okay, so this is what they are trying to say. Mass can neither be created nor destroyed in a chemical reaction. But there are two cases in this theory. Let us try to understand case one. So what does the case one says? When reactant is completely consumed. When reactant is completely consumed. So what is the meaning of consumed here? Consumed means utilized. Okay, let us try to understand the case one here. Suppose if I take a chemical reaction, A is giving rise to B. Okay, so when T is equal to 0, what is the meaning of T is equal to 0? Reaction has not been started. Okay, reaction has not been started. Okay, now what happened after some time? That means T is equal to T seconds. Always remember what is the meaning of T is equal to 0? Reaction is not started. When reaction is not started, you are not going to get any product. Okay, now what happened here in this case? After some time, T is equal to T seconds. What is the meaning of T seconds? 5, 10, 20, 30, whatever you want, you can take that. Okay, so after some time, what happened? Out of 100 grams is utilized. So how much you are going to get here? 100. Okay, so that means what you are saying. So what is the before, Nana? So what is the formula we can take here? Before total mass. So for this case, what you can write, total mass of reactant is equal to total mass of product. What is the initial mass you took in the reactant? 100. Okay. So after also how much you got? B plus C overall 100. Can I say LHS is equal to RHS here? Right. Let us go with the next one, case 2. So what happened in the case 2? Sometimes. Okay. So what we can say, when reactant is partially consumed. When reactant is partially consumed. What is the meaning of partially consumed or partially utilized? So in sometimes what happen, when you take 100 grams, out of 100 grams, only 30 grams is involved in chemical reaction. So this type of cases also we can see in the experiment. Okay, for example, if I take A gives rise to B plus C. Okay, when T is equal to 0, I took 100 grams. So do you get any product here? No. Why you are not able to see the product? Because T is equal to 0. What is the meaning of T is equal to 0? Time is 0. What does it indicate? Reaction is not started. Okay, when the reaction is not started, you are not going to get any product. Okay, now moving to the next one, when T is equal to T seconds, that means after some time. Okay, just now I said out of 100, only 30 grams is used for the reaction. That means leftover is how much? 70. And how much product you can see here? 30 grams of products you can see. Okay, so what does the second case says? That sometimes because of some errors, what happened, out of 100 grams only little amount is going to involved in the reaction. Okay, so if like that happen, then what will be the formula? So then the formula can be given as total mass of reactant is equal to total mass of product plus mass of unreacted unreacted reactant unreacted reactant. Okay, that means what is the initially we took, Nana? 100. Total mass of product, how much you got? 30. How much is not involved in the reaction? 70 grams has not been involved in the reactions. Can I say 100 is equal to 100? That means LHS is equal to RHS. Okay, so but there is one exception, Nana, so write down here exception. Okay, so what is the exception? You can say, Nana, here the exception is nothing but this is not applicable for nuclear reaction. So this law, the above law, okay, so the above law is not applicable. The above law is not applicable for nuclear reactions. For nuclear reactions. Okay, so now the question is, ma'am, what happened in nuclear reactions? Why this law is not applicable? Okay, so generally when you go with the nuclear reactions, what happened, sometimes in the nuclear reaction some of the energy, some amount get converted into the energy, and that energy is going to escape. Okay, for example, if you took 100 grams, okay, out of 100 grams, what happened, 30 grams is converted into energy and it is escaped. Okay, now you are left with what? 70 grams. Now LHS is equal to RHS? No. Why it is not equal? Because 30 grams has been converted to energy and energy is escaped. So that's why we will say for nuclear reaction, this law is not applicable. Okay, right. Let us go with the next second one, Nana. So coming to the second one, law of definite proportion. Law of definite proportion. Law of definite proportion, or no, so sometimes in the books what happen, instead of giving definite proportion, sometimes he will try to give the heading law of constant proportion. Okay, so let us try to understand what is law of constant proportion. Okay, so let us see what is the meaning of law of constant proportion. Okay, so let us try to write down. First of all, it is given by Joseph Prost. Joseph Prost. Let us try to write down here. A chemical reaction have same element. A chemical reaction have same element combined together in a definite proportion by mass, comma, irrespective of the source from which it is obtained. Let us try to understand the meaning of this sentence. So what does it is saying? It says that a chemical reaction will have same element, both are combined together in a definite proportion by mass, irrespective of the source from which it is obtained. So let us try to understand what they are trying to say us. For example, if I take H2, okay, and now what is the H2O, right? What is the hydrogen is to oxygen, Nana? That is nothing but what is the weight of hydrogen? 2 grams. Oxygen is 16 grams. If I go for further simplification, do you get 1 is to 8 ratio? Yes or no? What you are going to get here? 1 is to 8 ratio by mass. Can say this is nothing but mass ratio. Now what happened? Suppose if I take C, if I take seawater, okay, now I'm not talking about composition, what are the components present inside the seawater. I'm not asking that. I'm just asking that what is the water formula which is present in the sea. Can say there also formula is H2O. Okay, suppose if I take rainwater, okay, so whatever the water which is present in the rain, what is the formula of that water? The formula of that water is H2O. Repeating again, I'm not asking composition of rainwater. I'm just asking whatever the water you are getting from rain, what is the formula of that water? Is it nothing but that is nothing but H2O, right? Suppose if I take tap water, so whatever the water coming from the tap, the formula is nothing but H2O. Okay. So suppose if I'm preparing in the lab, okay, lab how to prepare water? H2 plus half O2 gives rise to what? H2O. Okay. Can I say everyone has mass ratio 1 is to 8? Right? Their mass ratio is how much? 1 is to 8. So this is nothing but what? Law of constant proportion. What does the law of constant proportion says? When you take one compound, if you prepare in the lab, if you prepare in the different method, for example, if I take the water, whether I bring water from Africa or India or rainwater, seawater, tap water, wherever you want, you bring the water, but the mass ratio is always constant. So that's why we'll call it as what? Law of constant proportion. Clear till here? What is the meaning of proportion? Value, mass value will be constant. Whether you bring, if someone is performing experiment A, other persons are performing experiment B. Okay. So now what happened? Whatever the experiment they perform, okay, the value of the water is, ratio of the mass of water is always 1 is to 8. Clear till here? I hope you people understood this theory. Let us go with the next one, third theory. So the third theory is nothing but law of multiple proportion. Law of multiple proportion, right? So let us try to understand the law of multiple proportion here. So let us try to write down here. Write down when two elements combine to form more than one compound, comma, then mass of one element combines with fixed mass of other element where a simple ratio to one another. Okay, so let us try to understand one by one point. By reading the point, we'll try to understand. Okay, so what is the first point they have given? When two elements combine. Okay, for example, if I take the two elements example, I will take hydrogen and oxygen. Okay, when two elements combine, combine to form more than one compound. Let us see what the more than one compound. For example, first compound is H2O, second compound is H2O2. Okay, when two elements combine to form more than one compound. Okay, next what they have given, mass of one element combines with fixed mass of other element. So let us try to understand here. So what is the hydrogen mass and oxygen mass? Can I say here hydrogen is 2 grams, oxygen is 16 grams. Here hydrogen is 2 grams, oxygen is 32 grams. Okay, so what they are saying, just try to recollect it, what they have given. Right. So what they are saying, the mass of one element combines with fixed mass of other element. Can say this is our fixed mass. Mass of one element combines with the fixed mass of other element, bear a simple ratio. Now what is the ratio of 16 into 32, which is nothing but 1:2. Can say this is nothing but our simple ratio. What is the meaning of simple ratio? The ratio, the one which further we cannot do any calculations. Okay, so here this is not the simple ratio. Why? We can take 16 ones are 16 twos are, but can you cancel this further? No. So this is, that is the reason we'll call it as what? Simple ratio. Okay, so this is nothing but what? Law of multiple proportion. So what is the difference between law of multiple proportion and law of constant proportion? Okay, so in law of constant proportion, we take one compound and we talk about the different sources. Okay, like tap water, rainwater, etc. Whereas in law of multiple proportion, we take two elements and try to produce two to three different compounds. Okay, just simple example, one compound, we are talking only about one compound, means constant proportion. Different compounds means multiple proportion. Okay, I hope you people got the clarity about this. Right, so this is what about the laws. Next one, let us go with the next one.